All right, Algebra 2, let's talk a little bit more about factoring. Okay, now we're going to talk about mastering factoring. So we're going to use the structure of polynomials to identify factors. Okay, opening. Factor each of the following expressions. What similarities do you notice between the examples in the left column and those in the right? I'm actually going to let you do these on your own, if possible. So go ahead and try them. Let's see if you can figure them out. Okay, this one may have been a little tricky to you, and I'm going to show you a trick here in a little bit to see if it'll help you. But the other three should have been somewhat easier for you to figure out. If I talk about C just a little bit, if there's no A term, you can take the C term and just list out factors. 1 times 15 and 3 times 5 are the only things that multiply together to get 15. And then you look at the B term and you try to match the factors of the C term that add together to give you the B term. Okay? So that one was pretty okay. This I have an A, so it's a little trickier, but we'll talk about that in a minute. Okay? 2 more. Go ahead and try them. I'm going to push pause. Okay, here you go for the last 2. I don't know if F was tricky or not, but you could factor the x squared minus y squared term again, which is sort of fun. Here we are talking again about the difference of squares and sort of what fun you can do with it. So write 9 minus 16 x to the 4th as the product of 2 factors. So really we're going to say 3 squared minus 4x squared squared. And then I can write the product of 2 factors. So 3 minus 4x squared and 3 plus 4x squared. Nothing too crazy about that one. Okay, how about the next one? Okay, it may get slightly more confusing, so let's go ahead and break it down. I've got 2xy squared minus 5x squared z to the 3rd power squared. Now I can factor it. 2xy squared plus 5x squared z cubed, that's a cubed. And then 2xy squared minus 5x squared z cubed. Okay, and that's as far as I can take it. Okay, this next exercise, it gets just a little bit trickier because I have that A term, which really throws me off. And what I would try to do is look through each one of these terms and think, can I factor anything out to make it a little more reasonable, to make everything make sense just a little bit better. And it doesn't look like I can. But let's see if I can break this down into smaller pieces and see if that helps you. Let's see, I can go 2x squared plus 2 times 2x minus 63. It's a little trick that, that we're learning. I'm just going to go ahead and say I'm going to replace that 2x with a variable just to see if I can show you a trick. So u squared plus 2u minus 63. Let's look at factors of 63. I've got 1 times 63, 2 doesn't work, 3 times 21. I'm looking for things that if I add or subtract them, I get 2. 4 doesn't work, 5, 6, 7, ooh, 7 times 9. Oh, the difference of 7 and 9 is 2. So that's what I'm going to use. I have u plus and u minus. Now, when I multiply them together, I'm going to get a negative, but when I add them together, I'm going to get a positive. That means that I need my 9 to be positive. So u plus 9 and u minus 7. If I FOILed that back, I would get the trinomial previous, so it works. Now let's go ahead and replace the u's with what we said u was equal to, which was 2x. So 2x plus 9 and 2x minus 7 are my factors. Pretty cool. Okay, let's see if we can make any sense with this part B. First thing I do is look through the trinomial and say, okay, can I factor anything out to make those numbers smaller? Because they're a little bit too big right now. I can take a 3 out. I'm left with 4y squared minus 8y minus 5. That's cool. Now let's see if I can do the whole u trick with it. So I have 2y squared minus 4 times 2y minus 5. U squared minus 4u minus 5. And again, here we're looking for factors of 5. 1 times 5 is it. And the difference of 1 and 5 is 4. Cool. So I have u plus and u minus. So when I add these two factors together, I'm going to have a negative answer. So I want my 5 to be the bigger of the two. Because if I FOIL it, I get u squared minus 5u plus u, which gives me a negative 4 in the middle. Now let's fix that. Put the u's back in. Oh, I said u was 2y. 2y plus 1, 2y minus 5, and I am completely factored. Good job. Okay, factor each of the following and show that the factored form is equivalent to the original expression. Here I have the sum of 2 cubes and the difference of 2 cubes. Let's do a little review here and give you what the sum of 2 cubes and the difference of 2 cubes is. It's been a little bit while since we've looked at it. So I have x cubed plus a cubed, and that gives me x plus a, and then x squared plus ax. Sorry, that's a minus. X squared minus ax plus a squared. And then x cubed minus a cubed is x minus a, x squared plus ax plus a squared. That's our sum of 2 cubes and difference of 2 cubes. Now let's go ahead and use it. A plus 3, a squared plus 3a plus 9. I don't think I can break that down into anything more, but I did make a mistake. Caught it. Minus. Okay, this next one, I have x minus 4, x squared plus 4x plus 16. Very cool. To show that the factored form is equivalent to the original, you would have to distribute these back through and show your answer. Okay, last one. Okay, I can't quite do the difference of cubes, but it looks like I need to factor out a 2 first. X cubed plus 64. Cool. So I have a 2, and then x plus 4, x squared minus 4x plus 16 is our answer. Good job. All right, in this lesson we learned additional strategies for factoring polynomials. Okay, we know the difference of 2 squares, and we know this. The new part is trinomials can often be factored by looking for structure, then applying our previous factoring methods. I'm going to show you another trick here and another page, so don't stop on me yet. One more slide. Okay, let's try this one. We're trying to factor it. What someone taught me quite a while ago is a fun little method that works every single time. And what you do is you plug in, let's make a little note up here, AC up there and B down here. So A times C is 9 times 8, which is 72, and the B term is negative 18 down there. Now we need to make a list of factors of 72. 2 times 36, and we're looking for things that multiply, oh gosh, I thought I hit the highlighter, multiply together to give me 72 and add together to give me 18. So factors that multiply to get 72 and add together to get negative 18. So in essence, we are looking for two negative numbers. 3 times 24, I think. Yep. These are all going to be negatives. So when I add these together, I'm going to get 18. 72 divided by 4. 4 and 18 doesn't work. 72, 5 won't work. How about 6? 6 times 12. Looks like we got it. Negative 6 and negative 12. That's what we put in right here. All right, now I need to pay attention to this A term right here. Okay? This A term makes some fractions on this part of the x, and this is how we're going to get our answer. So I have 9 over negative 6. I don't know why I drew a 9. 9 over negative 6. I can simplify that. Divide by 3 on the top and bottom. And this gives me my answer. 3x minus 2 is going to be one of my binomials. If you see this negative 2 just went right there, and that's where the 3 goes from. Let's do the other one. 9 over negative 12 simplifies to 3 over negative 4, and that gives me 3x minus 4. Let's write out our answer. 3x minus 2 and 3x minus 4. Now let's FOIL it really quick. First times first is 9x squared, outer, negative 12x, inner, negative 6x, and last is positive 8, which gives me 9x squared minus 18x plus 8. Got it. That's very, very exciting. The other method that we learned just today was to find our u's. 3x squared minus 3x times 6 plus 8. So I would have u squared minus 6u plus 8. 2 times 4, so u minus 2, u minus 4, which gives me 3x minus 2 and 3x minus 4. Just giving you another option. I hope I didn't confuse you. Good job today.